In this video, we're going to look at percent and different percent applications. Now the first one is just your basic percent. We have 54% equals some unknown amount over our whole or our base 88.5. We can multiply the 88.5 over to solve for our part or our amount and get 47.79. The second example, this time we have the amount and the percent, but we don't know the base. Again, same idea, we have the 12.7% equals 18.3 over the base, but this time we're trying to isolate the base. So multiply the base up, and then to isolate the base, we divide. And this will give us 144.1. In this example, we have 15 red M&Ms in a bowl of 80 M&Ms. What percentage is red? Well, the percent will just be 15 divided by 80. So P equals 0.1875. Times it by 100% to get 18.75%. The second example here, we have 43% of people drink coffee and we polled 200 people. So how many answered that they drink coffee? So 0.43. We're looking for the part or the amount, and we have the whole or the base, which is 200. So we can just multiply to get A, which will be 86 people. There are a lot of applications of percent in retail and business. Here, we're working with increase. So the markup or increase is 55% on a $1,200 item. So we take the 1,200 and we times it by the percent. We get $660. This is the amount of markup. The selling price, you'll take the 1,200 and add 660 to get 1,860. And this is the selling price of the couch. Second example, we're just looking for a selling price, but we can use the same approach. 150 times 0.4 equals 60, and then 150 plus 60 equals $210 for the coat. We can also do percent decrease, so something going on sale. So here, we take the 850, times it by the 15%, which is 127.50, and then we do 850 minus 127.50, which gives us 722.50 for the sale price. Here, next example, we have the sale price and the original price, but we want to know how much markdown that was. So we're going to have to do the 1197 minus the 597, which is 6, and then the percent will be 6 over 1197, which ends up being about 0.5013 or 50.1%. Now, this last example kind of leads into my next application, which is percent change. We could have done this using the percent change formula, and it would have worked out just the same. So here we have the percent change. So change is equal to 360 minus 325 over 325. Remember, it's new value minus old value over old value, or new value minus original over original, or whatever way you want to memorize it. In this case, we will get 0.1077. So there's a 10.8% increase in pollutants. Next example, same idea, C equals, we're going to do 140 minus 480 over 480, which is negative 0.7083. So therefore, there is a 70.8% decrease in temperature. Now, I am going to be looking for the words increase and decrease when you're doing these questions. Let's do a couple more examples. This first one is what we call a percent efficiency. It's really just basic percent, just with given a different name. Your efficiency will be your output over your input. In this case, we get 0.8046. So the motor is 80.5% efficient. Last example is percent error. Percent error is very similar to percent change. Now with percent error, you do the measured value minus the calculated value divided by the calculated value. This will give us 0.1607, so there is a 16.1% error.